Today we're going to make an alarm system that sends you a text message when triggered. Welcome to Jim and Joe's. At the heart of the system, we'll be using an ESP8266 12E. The ESP8266 can act as an access point or a station that connects to an access point. As an access point, other devices can connect to the ESP8266. And as a station, it connects to an access point. Because the ESP8266 12E works with 3.3 volts, we'll use a LD33V or LD1117V33 voltage regulator to protect the board from being destroyed by too much voltage. So pin 1 goes to ground. Pin 2 is your output that spits out 3.3 volts. That'll go to our rail. And last but not least, the third and final pin goes to the 9-volt battery. And now we connect our ESP to the ground rail and 3 volts to the 3-volt rail. The ultrasonic sensor works with 5 volts. We're going to use a L7805CV or an LM7805 to regulate the 9 volts down to 5. The first pin goes to the 9-volt battery. The second pin goes to ground. And last but not least, the third pin, which shoots out the 5 volts, goes to our positive rail. For the ultrasonic sensor, pin 1 is ground. The echo goes to the ESP D5. The trigger goes to the ESP D6. And the fourth pin goes to our 5-volt rail we just set up with the regulator. We're going to use a single channel relay to power the buzzer module, which is the speaker that'll make the loud noise when the sensor is triggered. The first terminal will go to the buzzer module, with the second one going to the 9-volt battery. The yellow wire of the relay goes to pin D2 of the ESP, with the red going to the 5-volt rail and the black going to ground. A red LED will be added to the system to let us know when the system is armed or unarmed. We'll use a 100 ohm resistor to protect the LED. This is connected to ground as well as being connected to the negative pin of the LED as a pull-down resistor. We then connect the positive pin of the LED to D1 of the ESP. A toggle switch will be added to arm and disarm the system, and its leg is connected to the 3.3 volt rail. The other leg of the toggle switch is connected to D0. When the system comes on, it takes 20 readings. It'll take those readings and average them out, and then subtract 85% from it, so it's not always sending you an SMS message and triggering the alarm every time it hits the wall. So let's arm the system. The red light goes away, and now if we place something in front of the sensor, we'll get a loud sound and an SMS message. The system is now unarmed again. And we did get a message telling us that the Hall sensor was triggered, and it gives us the date and time. When you get our DIY kit, not only do you get the components you saw, but you also get the code, and you get this STL as a download. You could download the STL and 3D print it yourself. It has 2 compartments, one for the components, and in the back, room for the battery. Links to this DIY kit is available in the description. And now that our circuit is complete, let's look at the code. Okay, so first you sign in. You can sign in with Google or just using a regular password. So I'm going to enter mine here. And so once we're set up, we go to My Applets and then New Applet. And then click on the plus of this. And we're going to type in Web for webhooks. Then we click on Receive. And then we're going to enter in a name. Create trigger. Then click on plus that. We're going to search for Gmail. And we want to send an email. And so we want to be able to put in whatever phone number for the text message. So we'll add an ingredient of value 1. And this can be any subject you want. I'm just going to put alarm triggered. And then what we want the body of the text message to say. So we could put hallway or living room. So we're going to have value 2. And then we're going to put a time on there. And then we're going to create the action. And as we see, it was created. We click Finish. If you click on the gear, you can go back and change whatever settings you want. So under your username, if you go to Services, you'll see you have your applets and you have your services. Over here we have Webhook. So we're going to click on that, and then we're going to click on Settings. Now this, after the use slash in the URL, that strange looking alphanumeric there is what you're going to need for your maker key. So copy that. Also, just be aware if you click Edit Connection, it's going to keep changing that maker key right there. So be wary of that, or you could render your other applications that you make useless. And that is about it. Let's look at the code. All right, so we import the ultrasonic library, and I'll put a link for that. And then we import the ESP8266 Wi-Fi library as well, and web server. Then we instantiate an object of Wi-Fi client, so we just say Wi-Fi client. And we set up the ESP8266 web server on port 80. And some of these other variables here we'll talk about when we get to the code. It'll make a little bit more sense when we see it. So we're going to skip down to maker key. This is where you put in your key that you got from ifttt.com when you set up your webhook. Here's where we define the maker event name. So in the example we called it mailer. A variable that just checks to see, well, a variable that I set to true or false when it's connected to the network. And here's where you'll put in your SSID and the password to your router. SMS is where you put in the phone number that you want to send the text message to. That's where we set up an ingredient of value 1 when we were setting up the webhook. Wi-Fi connect timeout of 40. So this is going to be where we have the max number of times to try connecting to the network. As stated in the circuit part of the video, the sensor will, or the whole circuit will turn on, and it will take 20 readings from the wall. And it'll take that and average them out, and then take a threshold of 85%. So average, this is where we store that average. Take 20 readings, average them, and take 85% of that average. So we want to leave a little bit of space between, like say you place this in front of a wall. If we're triggering it every time it hits the wall, you're going to get SMS messages all the time. So we want to give a little bit of lee room so you can pass in front of that and actually trigger it. Next, we set up the ultrasonic sensor. The 12 and the 14 represent the echo and the trigger pins. The relay pin, that's what triggers the speaker. It's on pin 4. The LED, which shows whether it's armed, or at the very beginning when it's taking readings, because it will flash 20 times or however many times you want it to, which you set it here. So that's going to pin 5. The armed switch, that's the toggle to put it into armed mode, is on pin 16 of the ESP. So moving on to the setup. We set up the pin modes. The relay is an output. We want to switch on the speaker. The LED, of course, is an output as well. The pin mode of the arm switch is going to be a pull down. The arm switch is, of course, what toggles the whole system on and off. We set the relay to low, the LED to low, just to make sure everything is off. We make sure the Wi-Fi is disconnected, and we wait 3 seconds. This function is what we use to connect to the network, so we pass in the SSID and the password of the router of your system, and here's where we start getting average readings. Let's go ahead and move down to connect to network. As you can see, it takes a SSID name and a password. Is connected as false. Wi-Fi begin. So we pass an SSID name and our password. Here we have connect tries. And here in this while loop, we're saying keep on trying to connect until the Wi-Fi status equals connected. Okay, so let's go over that again. Keep on going while this status does not equal, that's what this exclamation is, it stands for not, does not equal connected. So as soon as it does equal connected, it's going to fall out of this because that's going to become true. Connect tries, we're going to plus equal 1 there. We could just do plus plus. But anyway, we connect tries plus equals 1, so that's going to keep on incrementing it. So it's going to start off as 1, and then it comes through this loop again. It's going to turn to 2 and 3, and as soon as it hits the Wi-Fi connect timeout, which currently is 40, we're just going to give up and break. So that just jumps out of everything, and we essentially give up. And here's where we print out whether it's connected or not. So the Wi-Fi status equals 3, then print to the serial monitor connected to Wi-Fi network. Otherwise, could not connect. And that's just kind of a debugging thing, and that's just a short form of doing an if. Next we have if Wi-Fi.status equals 3. So 3 means it did connect, as we showed up here. So if it did connect, let's set is connected equal to true, and send ourselves a test SMS saying connected to Wi-Fi network, which I originally had that in there for debugging, but I decided later that was a really good thing to keep in there because it'll let you know that at some point there was a problem in the network, whether your Wi-Fi lost connection or there was a problem with your provider, and then it came back, you would get an SMS message and you would realize, oh, there was a problem. It's just a really, I thought, good thing to know. If it does not equal 3, so it didn't connect, we go ahead and set that to false. And right over here, I print out the local IP address. That's not necessary. Again, it's a kind of debugging thing, but it may be a nice thing to know. And then I return the status. So is connected equals false or true. So that is why this is a Boolean. As you can see right here, I have a return type of bool, which is true or false. So this will return whether we connect it or not. So here's get average readings. This is where we're going to take the readings of the sensor and take an average of that. So here we set the LED to low to make sure it's off. And then we go into a loop. And we're going to loop 20 times because that's what we set up above. And here we have ultrasonic distance read. So we're going to request that the sensor gives us a reading, and we're going to save it to average. This plus equals means keep on adding to it. So if the first time around it's 50 and then it comes back around and it's 60, average will now be 110. We set the LED to high and wait 500 milliseconds, and then we set it to low and wait another 500 milliseconds. So what that's doing is that the LED, every time it takes a reading, it's going to come on and go back off and come on and go back off. It's kind of a visual indicator, so you know that you're in get average settings or get average readings mode. And so then we jump out of that after 20, and then we actually do some calculations here. So we take the average and we divide it by the max readings, which currently is 20, and then we get 85% of that. And here I'm just printing out some stuff showing the average, again, debugging stuff. So that brings us to our loop. First thing we do is set armed equal to false. And then we check to see if the toggle switch is armed or not. If it reads back high, we set armed equal to true. That brings us to this if condition here. If that toggle switched is armed, and this is a shortcut for saying true, you could also do this. If armed equals true, request a reading, save the reading to an integer called reading, and check to see if reading is less than the average that we took up above. If it is, set the relay pin to high, which triggers the sound, and send an SMS message. Now, this right here, this should be broken out to a variable, a global variable up top, where we define max readings and all that stuff. So I will take that out and make it a char star, but feel free to hard code it in if you want, but that's really not a best practice. So we send the SMS. We wait 8 seconds, so we wait 8 seconds because we want that sound to be going off for 8 seconds to hopefully scare somebody. And then we turn the sound off. Right here is where we check the other possible mode of the circuit, and that's unarmed. So if it is connected to the Wi-Fi but unarmed, then we print out some stuff to the serial monitor, again, debugging, and we flash the LED. So the LED is going to turn on and off to let you know that you are connected to the network, but it is unarmed. Now, we have another state that's possible, and that is we had a problem connecting, and it's unarmed. So if we couldn't connect to the Wi-Fi and it is not armed, then we flash the LEDs in a different sequence because there's no LED display on there where we can read out what's going on. We have this light that turns on and off, flashes, and lets us know what's kind of going on. So that brings us to send SMS. This function takes one argument, and that's the message that you want to send to the phone. In this if, the first thing we really check is if we're connected to the if this then that website on port 80, and then we set up the keys. This is all the stuff that the if this then that webhook is going to need. All this right here, we're just building up this long URL, like a query string type URL that we're going to send off to if this then that. So we have the maker key, we have in this section, we have the value. So here's the phone number that we set up. Here's value 1 when we added the ingredient in the if this then that widget when we're building it, the actual number. Then value 3 equals this message that we passed into the function. So we're just building up this long query string. So right here, we're doing more cleanup, getting it ready, and finally just posting it. Client.print actually sends all this that we just kind of built up and ships it off to if this then that, so we can take that parse through it, and trigger the SMS text message the way we want. Client.flush simply cleans up the variable. That's a really long discussion, but basically you're taking the client and you're just cleaning it up. You're closing it, if you will. This is available as a download. You get the DIY kit, you'll get the code, you get the fritzing, you'll get the STL. So thank you again for joining us on Jim and Joe's. Please like, subscribe, and share this video with other people that are interested, and have a great day.